Hello, everyone. This is our final project, and it will be presented by myself, Jose Gomez.
Arnav Thakur.
Hello, this is Omer Sumeri.
So for a project idea, we have a solar panel, which is supposed to power the breadboard, which then powers two LED lights, which are hooked up through jumper cables and two resistors connected to the STM32 board, which is then connected to our computer, which has the STM32 software, which is then connected to a terminal software. We are using Mobile Xterm. The result should be when there's voltage, the software should say the LEDs are on. When there's no voltage, the software should say LEDs are off.
For the components, we would all use STM32 board, 18 volt solar panel, Mobile Xterm, the serial terminal software, and also two limiting resistors, one 200 ohms and one kilo ohm. Another thing will be using two LEDs, a breadboard, jumper wires, and most important, a ray of sunlight, or in our case, a lamp. One thing I worked with Arnav was we worked on breadboard on campus. I was working on LEDs and putting all the components together with the STM board and the breadboard in order to work with the code that Omer created.
So for the board setup, as you can see on the picture on the right-hand side, the two LEDs hooked up with two resistors. The top one is a 200 ohm. The bottom one is a 1 kilo ohm. They're both connected to our STM board on both sides, two pins P3 and 4. If you can see the red and the black cable, those are the two connectors that are connected to the solar panel. On the picture on top, you can see the solar panel. And since the project was done at night, we used a lamp. I covered the solar panel with a cardboard box, and then that's why there's no light on the LED. Now, when I uncovered the solar panel, therefore no cardboard on it, in the picture on the right-hand side, you can see that the LEDs light up, which then means that these LEDs have enough voltage to send the signal through the STM board to the STM software and to the terminal.
So now that Arnav and Jose took point on the hardware, I took in charge of the code. So I created the project, set all the pins, which is PB3 for GPIO input and PB4 for GPI output. To talk about the code in depth, so we had to initialize two functions. For the first function was the UART function, which transmits data between two devices, the STM and the data that is being transmitted if the LED is on or off from the STM board to the Mobile X terminal, and also the GPIO input init function. So our code can be split into the if-else statement. And the first if statement is if the LED is on, which outputs a message saying LED is being powered by solar panel with also a counter mechanism. And of course, if that if statement is not entered, the else statement is entered, which says LED is off, and everything just keeps looping until we terminate the program or stop the STM ID Q32. So moving on to the next slide. So the Mobile X terminal, this is a picture of our Mobile X terminal displaying if the LED is on or LED is off with the two counters that we included into our terminal. Next slide.
There was various things we learned. This project brought us out of our comfort zone. For example, myself, I'm not really into coding or don't know much about coding. So that's when I stepped in and helped a little bit with Omer, just with the bit user code too, just as simple as putting characters together. We couldn't fully understand. We also helped each other when we couldn't understand certain tasks, and everyone stepped up in order to complete one big task. And this is what we got out of it. Next slide.
So speaking about how this project benefited us, so we were able to work with microcontrollers and how to integrate the STM32 nuclei board with external hardware, which was the software, the solar panel, and also working with software of the serial terminals. We work with external software and external hardware We use renewable energy with the solar panel. And we also demonstrated our knowledge of using code in our project when we integrated the if-else statement in our STM32 ID cube project. So that is the end of our presentation. Thank you, and thank you for your time.
Thank you.
Thank you.